Hello everyone. In this session, I will be explaining about the most important and interesting pattern, which is singleton pattern, and this is the most popular interview question that is being asked in many interview questions. Where if design pattern topic comes, so the first question that is being asked is, have you worked on singleton pattern, or what is singleton pattern, or write a program on singleton pattern. So this is one of the interesting design pattern. And according to the Wikipedia definition, so the singleton pattern is nothing but it ensures a class has only one instance and provide a global point of access to it. Okay, so let us dig deeper into this. So what is this class has only one instance and provide a global point of access to it? Uh, and what is actually what is actually class has only one instance? So basically, uh, singleton we have abstract factory, which we have studied in so in the same category of the design patterns. So the singleton same. So what is the intention of creation patterns? So the strategy of creation patterns is to create an object based on the if you see earlier what we have studied in factory pattern or abstract factory pattern. So these also create objects. So factory pattern creates the objects and abstract factory creates the factories that creates objects, which is one level higher than the factory pattern. And singleton also create object, but it creates an object only one object for the class. So one object for the class. So till so I can add the definition here till the complete application life cycle. So what do you mean by the complete application life cycle? I'll explain. Say for example, in Java, in Java memory, I'll be taking one session also on JVM and Java memory handling. But as of now, in I'll be explaining. So in Java memory model, in Java memory model, for example, so all the memory will be residing in JVM, and in JVM, all the objects are located in heap memory. All the objects are located in heap memory. So in heap memory, uh, all the objects are located. Say how actually an object is created in Java. So the traditional way of creating an object is suppose I have a class. I have a class. So in this class, I can have multiple objects. So an object is nothing but a real-time entity. Okay. So I can create an object of this class using new operator. So new of that class, that new of the constructor name. So new. So if the class is having, so I'll give the constructor. I'll create a constructor. I'll invoke a constructor of this class to create an object. So how many constructors I invoke, so those many objects are created in the heap memory. Those many objects are created in the heap memory. So this is a traditional way. But in singleton, what will happen is, so the object of this class, suppose if this class is a singleton, the object of this class is only one object throughout the entire uh, life cycle of the application. Throughout the entire life cycle of the application, the object is only one object. What do you mean by the life cycle of an application? So the life cycle of an application starts, or the life cycle of a Java object starts when JVM starts and when JVM shutdowns. Okay. So a JVM, when a JVM starts, so a JVM is linked to a server. Okay, JVM is linked to a server. Imagine that a JVM is linked to a server. So when a server is started, so JVM starts and it actually loads the objects that are created. And when JVM is shut down, so it will get shut down. Even the objects will be deleted. Okay, and the singleton object will be uh, and also between JVM start and JVM shutdown, there might be garbage collections also happen, and these garbage collections also, because of this garbage collection cycle, even objects also gets deleted in the JVM. But let us assume we have a singleton object, so that will be not be garbage collected, and it will be created at the time of JVM startup, and it will be deleted at the end of JVM startup. Okay, this is one scenario. There is might be one more scenario where I start when the JVM is started, and I invoke a singleton class to get the object, and then only the object is created for the first time. And how many times I invoke this class, okay, the same object will be returned to me, and this object will be there till the JVM shutdowns. Okay, so this is another scenario. I'll be explaining all these scenarios. So as of now, so singleton means how many times I invoke a class. It is only one object, okay, per JVM. It is one object per JVM. Okay. Now, uh, now how actually what is the benefit of the singleton pattern? And definitely, obviously, we can see the straight benefit, because in any object in JVM will be stored in heap memory, and if I have only one object, that means I'm saving the heap memory. I'm saving the heap memory. That means I'm increasing the performance of the application. So when I save the memory, automatically the memory will be optimized, and you'll get more memory, and you can create other objects also in the memory. You'll have space to create other objects also in the memory. But but since actually only one object is created in the heap memory, so can I use actually the singleton pattern in all the cases? No, I cannot use a singleton pattern in all the cases. Why? So I'll get an advantage that it is only one object and I can save the memory. But why can't I use singleton pattern in all the scenarios? So why I will be using in my Java programs, writing new of the constructor and creating the objects wherever required. Why can't I use singleton pattern in all my business scenarios? It is not the scenario. See, for example, I will actually uh, explain this scenario. Okay. Say, for example, I have a DB database, and I have a application. Okay, let us actually I'll what I'll do is I'll draw here. So I have an application and I have a database. Okay, and this application, say it is a web application. For example, let us assume this is a web online application. So when I say web online application, so multiple users can invoke this application. So that means multiple users can pass their request to this application. Okay, and in this application is running in a web server or an application server. So when the application is running in web server or application server, so each request is mapped to one thread. Okay, so I hope actually most of the people who are viewing this video are familiar with thread concept in Java. If you are not familiar, then anyhow I'll be taking one video session on Java multi-threading, which is very interesting and very important topic in Java. So I'll be taking one separate session. As of now, who understand thread, they can understand this, they can correlate this concept. Now, each request is associated with one web server thread, with one application server thread. Okay, fine. Now, now what will happen? Now each thread will so whenever a thread is associated with this thread is created by the web server. This thread is created by the web server. Okay, because web server also runs in if it is a Java web application server, it runs in a JVM thing. So this thread is also associated with one request. I mean, this request is also associated with one thread. Now, so for example, say I have three threads coming now. Now we'll talk in terms of threads now. Okay, each user request is mapped to a thread. Say three user requests are mapped to three threads, and these three threads are invoking DB database. How they are invoking? So there is a class called DB connection. So I mean, this DB connection is the application related class. So this DB connection, and they each thread will create its a DB connection object, and then using the DB connection object, they go to this DB using JDBC, or JDBC is the basic core protocol or core mechanism that gets actually where the database access is invoked. So this DB connection object is created for each thread. Okay. Now, and each thread will have its own object, and on this DB connection object, they will actually issue SQL queries, update statements, and everything, and they close the connection object. Okay, the connection object gets destroyed. Now, so here what is happening, for each thread I'm creating one DB connection object. Now, instead of that, let us make this DB connection object as a singleton. Let us make this DB connection object as singleton. So what will happen in singleton in DB connection object? Now, if I make DB connection object as singleton object, so all these three threads will be pointing to only one object, only one object. Now, what will happen is this thread can do fastly. That means it has only some 2 or 3 SQL statements to be processed. But this thread is having around 10 to 15 SQL statements to be processed, and this thread is having around 50 to 60 SQL statements. That means this thread uses the DB connection, which is a singleton object. It just processes 2 or 3 SQL statements and closes the object. But this thread still, it is processing some 10 to 15 SQL queries. Still, it is in the middle of the processing, and since the connection is closed by the first thread, this thread will get interrupted, and the third thread also, which is actually which requires around 50 to 60 SQL queries to be processed, even it is in the middle of the processing. So, and since the first thread has closed the DB connection object, because it is done with it has been done with with its work, because the first thread is just only 2 or 3 SQL statements to be processed. So since it has done with its work, so it closes the SQL connection object, and thereby the second thread and third thread gets interrupted. So in this scenario, you cannot use DB connection as singleton object. Okay, this is problem. This is a very critical problem in the real-time application. Thereby, the other two user requests cannot process the data in their database from the application. So that is why this type of scenarios, like DB connection objects, so these objects cannot be made as singleton. So these connection objects cannot be made as singleton. So I hope everyone is clear. So singleton cannot be used in all scenarios, only whenever required, and if the object serves globally for all the threads without any disruption. So then that object can be used as singleton. So where actually I can use a singleton? So I can use singleton here actually. 1 minute. So I can use singleton. I can use singleton in logger. I can use singleton in logger. I can have a logger object, and the same logger object can be used by multiple threads to log the request response that is being coming. So there is no interruption, because logger I can use logger object in singleton as a singleton pattern. Okay. Now let us actually dig deep dive into how we can create singleton pattern in Java, and we'll see what are the actually various ways of creating singleton pattern. Okay. So let me go straight forward into the Java program. So this is my singleton pattern, which is a logger class. And how can I create a singleton pattern? So let me actually uncomment this code. Okay. So this is my singleton pattern, and I create a class called logger. And what I'm doing here is I'm creating a static member uh, with the logger. I'm creating a static member which is assigned to logger object. So which is assigned to a logger object. So what is the meaning of this means? So what is static member? Static member means any static member in Java will be loaded at the time of class loading. Okay. So at the time of class loading, that means when JVM starts, so it will load all the static members of the particular class. So when the static member of the particular class is loaded, so the static member is pointed to creating a new logger object, and that logger object will be created and stored in the heap memory. And static members are accessed only one time, initially only at the time of class loading. And if you invoke this logger object multiple times also, only first time when the class is loaded, the static members are accessed. And so here this logger object is created and stored. Okay. And a reference logger reference variable has been assigned to this logger object. Okay. And this logger reference is a static member. Okay. And this cannot be changed again and again. Okay. And that is the first step. The second step is I'm making the logger constructor as private. So this is most important in singleton. Otherwise, what will happen is, So why I'm making this as private? So why I'm making this as private means, suppose if I make this as public, if I make this as public, now anyone from outside this class, say for example an external service. So an external service, so anyone from outside this class like external service, they can actually create an object of this logger class by calling the constructor of this class, because this constructor is a public constructor. And when the constructor is public constructor, then any external service can create the object of this class using this public, because this is a public and an object is created. So that means how many times I invoke this constructor, so that many times those many objects are created for this logger. Then my singleton purpose is not solved, right? Because singleton means it should ensure only one object per JVM, the entire life cycle. Okay. Now I'll make this as private so that no one from outside this class can invoke the constructor. So it's just a private. Okay. Now, next, what I am doing is I am creating one static method. So this is a public method so that the external class can invoke this method to get the singleton object. Okay. So the static will return a logger type, and it will, now what I'm doing is here return logger. I'm returning logger now. See, the same object that has been created at the static time, at the time of a static reference, static member, I'm returning this actually. Suppose if I don't do like this, if I do like this, return new logger. Now what will happen now? Now every time I call, now say for example, now external service. Now what it will do, say let us say I'm creating one external service, and from external service, what I'm doing is I'm creating a method one in external service. In that, I'm creating logger dot get logger. Okay, what will happen now when I say service dot method one? What is the service? External service. So service dot method one means it will go to this method. So when I say service dot method one, now in this it will actually call logger dot get logger. What logger dot get logger is doing? When I say logger dot get logger, it is returning a new object of logger. Okay. Now again I call service dot method one just for fun. Okay, just for to understand. So service dot method one. So again it will call logger dot get logger and it will print logger. Now if you see, since actually this is returning new logger, now this whenever this get logger is invoked, so this new logger is invoked. That means a new object is being created. So that means now when I call two times this object, now I get two objects. Let us see. If you see here. See, this is one object and this is another object. See, so this is one object. Okay, this is another object because the object ID has been changed. Now instead of that, now I say just say logger. So I say logger. So what will happen now? I'll see. So when I run this program now, see, the same object is being written. The same object is written. So what will happen when whenever the class is loaded? So an object is being created initially at the first time, and the same object reference is being written every time when I call this get logger method. This is a very simple. So this is a very simple one. So we call this approach as eager initialization. So what is this? Why this is called eager initialization is this object is being created at the time of class loading itself and stored in heap memory. Now, basically, there is again an alternative. Here, what is happening is sometimes this method is never called actually. This getLogger method is never called from any external service. So, but the object is created initially and stored in the heap memory. So though this method is called or not called, so this object is created and stored in the heap memory. So that is why this is called eager initialization. Is there any other way? I want in such a way that even I should not create this object eagerly initially itself. Only when this method is called, only when required, I should get the singleton object. So for that, I go for lazy initialization. So this is one alternate way, and we can say this is actually a best way than the eager initialization. Though the eager initialization is very simple, but I'm creating the object though this getLogger method is called or not called. So for this, what I'll do, I'll just comment this code and I'll just give a demonstration on this. Now this lazy initialization. So what this lazy initialization will do is, okay, I'll just remove now. So what this lazy initialization will do is, I'll just uncomment this now. Okay. So what this lazy initialization will do is, now again, I'm just creating a static member, a reference, but now this is assigned to a null object. Now I'm not creating the object at the time of class loading. Okay, again, every time in any method, lazy initialization or eager initialization, the constructor should always be private. Okay, so that I'm not allowing any external service to invoke the constructor. Now, in this, what I'm doing is I'm just creating get logger in get logger. So if logger equal to null, so I'm checking. So what is this logger? This logger is a static member. Yes, logger is null for the first time when I invoke. Okay, so it will return an object new logger, return logger. Now, first time when it is invoked, so it is null, and then this logger object is created and assigned to the reference variable, and then this reference variable is returned back. Okay. Now, second time when it is invoked, now logger is not null. Okay, because logger is having now associated with the logger object now. So this condition will be false, and it will return the same logger object that is being assigned. Okay, so this is a very straightforward thing. Okay, but this will work in a single threaded environment. That means single threaded. So uh, I mean, people who are viewing this video, I think they might be familiar with multi-threading and single threading. If anything, I'll be putting the videos on multi-threading also. So what will happen in multi-threading and single threading? For example, this scenario, what I'm telling, the earlier one, which actually I have shown, that web server environment, the user requests that are coming. This is a multi-threaded environment. There, three requests are coming simultaneously to an application, and each request is associated to one thread. So there's a multi-thread environment. And in single thread environment, only single thread like this external service. This is a single thread. It will just invoke sequentially. In multi-threading, we'll get a concurrent parallel processing. Okay. So in parallel processing, what will happen is, there is a possibility that two threads can enter into this block. Two threads. Say for example, let us go with the simple scenario. Two threads are trying to access this single thread, singleton thread. So two threads, thread one, thread two, now can enter into this method. Easily they can enter because it is a parallel processing. So they can easily enter here. There is no restriction. And now, and they also can enter into this block also, into this if condition also, because two threads can see that logger equal to null, because parallelly they can read this logger reference variable. There is no restriction. So here there is no lock or anything. Okay, I'll tell you that. I think who are familiar with multi-threading, they can understand this lock concept. Here there is no lock or anything. Two threads can enter here, and each thread, this thread one can invoke this new logger, this thread two can invoke this new logger, and thereby a new object is created for two threads. Two separate new objects is being created in separate. If for two separate threads, then this is not a singleton again, because what singleton does, it should ensure only one object has to be created. But in this scenario, what is happening is thread one will get one logger object, thread two also will get one object, because each thread will invoke separately this constructor. Okay, there is a chance. Now for that, what we do is we will ensure a lock on this method. For example, we will ensure a lock on this method. So now what will happen when we ensure lock on this method? Now, now only when I say synchronized, okay? So again, this is a multi-threading concept. Who are familiar with multi-threading concept, they will be understanding about this. Synchronized is a method locking. Synchronized is a method locking. Okay. So only one thread, if a method is being synchronized, so that means there's an object level class. So if a method is being, this is a static method, so this is not an object level, this is a class level lock. Okay, if a method is being synchronized, if an instance method is being synchronized, that is an object level lock. If a static method is being synchronized, it is a class level lock. Okay, remember that difference. Anyhow, I'll take a deep session into that object level locking, class level locking in multi-threading. Okay. Now, so when I say synchronized, only one thread can enter into this method. Two threads cannot simultaneously enter into this method. Only one thread can enter. It will see logger equal to null. It will return a logger object and return. Now, second thread. So once the first thread comes out of this method, then it will release the lock. So first thread when it comes out of method, it will release the lock so that the second thread can enter into this. Okay, and second thread will see logger equal to null. No, because the first thread has already created the logger object and assigned to the static member. Now it will see the static member, it is null, no. So then it will return the logger. What this logger return? Logger is pointing to, it is pointing to the logger object. It will return. So now thread 3 also can enter. Okay. Now here it is now not a parallel processing. It's a sequential processing. If you see, only one thread can enter and execute this block. Try to execute this block. This is sequential processing. Okay. Now in this way, we are ensuring singleton is also achieved in multi-threading environment. But again, there is an alternative here. So what is the alternative here is, I am actually locking the method. I'm locking at the method level, complete method level. Okay, that means whenever this method is invoked, this is locked. The complete method is locked actually. Okay, generally this is also not a recommended way, because what will happen is I can allow multiple threads to enter into the method. Okay, they can process the other part of the code. Okay, in this scenario only there is only three lines code actually. They can process the other part of the code, but only in the critical sections that that part of the code should be locked. So that is why we'll go with one more concept called synchronized blocks. So which we call it as a synchronized block. This is a synchronized method. So there is one more scenario called synchronized blocks. So what will happen? Okay, I'll again comment on this. So there is a synchronized block concept. So in synchronized block, okay, I'll just uncomment this. Okay, in synchronized block, again, what we'll do is I'll just put static logger. Again, here also a private constructor. Any method you see, the constructor should always be private. Now what I'll do is I'll remove the synchronized from static method, and okay, now two threads can enter into this method easily. Even two threads can enter into this if condition easily. Okay, now I am putting synchronized on the logger class level object. Okay, I'm locking the class level. Now here only one thread can enter, only the first thread or second thread, whichever the operating system. Again, thread ordering, thread scheduling is not a C, is not, say for example, it is not like thread 1 always will execute first, thread 2 will, it depends upon the operating system scheduling. Okay, I'll explain deeper into that how threads will be executed by the operating system in another session. I promise you that, I assure you that I'll give you a detailed explanation on that actually. Okay, now, so say for example thread 1 will enter into this block. Okay, and it will create a logger object. Okay, now once thread 1 comes out of this block, thread 2 also can enter and it will invoke this object. Here I'm not checking the condition, only I'm checking the condition at this place, at the first place. So at this first place there is no restriction, so this code can be executed parallelly. Two threads can see a logger object null and they can enter into this if block easily. But here, once thread 1 is done with its work, now thread 2 will enter into this synchronized block. Again, it will create new logger object. Again, now here in this scenario, two threads, there is a possibility that two logger objects are created for two threads. There is a possibility here. Okay. So for that, we go with a very interesting concept called double checked logging. Okay. So this is what we call double checked logging. In double checked logging, okay, I'll uncomment this code now. In double checked logging, what we are doing is, again, I'm creating a logger reference, again a private constructor, and now in then static logger get logger. So here what I do is, now if logger equal to null, okay, I'm checking here one condition. Okay, now two threads can enter here simultaneously. Thread 1, thread, okay, two threads can enter. There is no restriction here. Okay, at the method level we have removed the synchronized, so two threads can enter here, two threads also can enter here. Okay, now only one thread can enter into the synchronized block, because now only in this section only one thread can enter. Okay, thread 1. Okay, thread 1 can enter now. Thread 1 or thread 2, that depends upon the OS scheduling. Now thread 1, it will see if logger equal to null L for the first time. Yes, it is logger equal to null, and thread 1 will get a logger object. Okay, and this logger object is returned. Okay, now before this logger object return, thread 1 comes out of this block. Thread 1 comes out of this block, that means it will release the lock. Now thread 2 can enter into this synchronized block. It will see logger equal to null. No, logger is not null, because thread 1 has already created the logger object. Now this code will not get executed for thread 2. That means thread 2, when it enters, though it enters into the synchronized block, this condition will be false, because, so that's why we call this as a double checked logging. So we are checking the condition at this place, and also we are ensuring that we are also checking if logger equal to null in the synchronized block, so that if one thread has released a log, second thread again will enter into that block, and it will see if your logger equal to null. It is not null. So this constructor is not invoked, thereby logger object is not created, and it will return the same logger object. So this is one of the beautiful concept which we call it as a double check locking in singleton pattern. So the advantage of this is now we are not creating the logger object at the initial stage, which is eager initialization, which you have seen in the first scenario. And also this works perfectly in multi-threaded environment. So we are ensuring that we are checking the logger reference object two times, one outside synchronized block and inside synchronized block, so that even in multi-threaded environment, the same logger object is being returned. Okay, this is what actually. In eager initialization, if you see, this is a very simple code. Even this works perfectly in multi-threaded environment. Why? Because first time the logger object is created and stored in the heap memory. That means before multi-threading starts itself, when the JVM loads the class, the logger object is created and stored in a heap memory. And multiple threads, when invoke getLogger, they return the same logger object from the heap memory. This works perfectly in multi-thread environment. Only thing is, this limitation here is, this logger object is created in the heap memory, even if this getLogger method is called or not called. So it is just created and stored, that's all. Okay, but here we are creating the logger object only when required. So that too for the first time when getLogger method is invoked in multi-threaded or single-threaded environment, first time it is invoked, it will create, and simultaneously in second time or third time the same logger object is being returned. So I hope everyone is clear on this. And if you have any comments, please post your comments. I'll reply to your queries, and see you in the next session. And I will be explaining about the other design patterns. Okay, thank you.